For our next lesson, we'll be going over arithmetic sequences. An arithmetic sequence is a progression of numbers, all with a common difference. An arithmetic sequence can look like this, but it doesn't necessarily have to end. It can just have dots to go on forever. The common difference is that if you take two numbers that are next to each other, and you take their difference, you will get some number d, and this d is the same for any difference. That means an arithmetic sequence can look something like 5, 7, 9, 11, 13, and so on, where the difference between each of these is 2. Now let's go over a little terminology before we proceed. There's the first term, which can be written as a1 or a sub 1, and there is the difference, or common difference rather, which is just the letter d. There's also the nth term, denoted an or a sub n. Note the relation between this and this. The first term is just the case where n is 1. One of the neat things about this is if I give you these three parts, you can find what I'm looking for. So let's say I tell you a1 is 5, and I tell you d is 2, then you know the entire sequence looks like 5, 7, 9, 11, 13, and so on. But if I wanted you to find specifically the case where n was 7, you could just go out and write the entire thing until you get to the 7th term. So in this case, the nth term is 17. But there are easier ways of going about this. What if there's the case where n was a big number, like 30? You don't want to have to write it all the way out until you get to the 30th term. For this reason, there's an easier way of calculating the nth term, and it can be written as a sub n is equal to the first term plus the difference times n minus 1. We can use this to answer the question from the previous slide. If you look at this, you may notice something interesting with the linear examples we were working with earlier. We have some number is equal to a constant plus a multiple of a variable. We can look at that a little more thoroughly. To see how this relates to a linear function, we can first realize that a sub n is very similar to f of x. It's really just where, instead of saying that, we're going to say like a of n, or rather a sub n. So we have our function of n, which we call a sub n, and that is going to be equal to, if we distribute n minus 1, dn plus a1 minus d. You can immediately see how this relates to y equals mx plus b. So we could graph this where the axes are n and a sub n. The y-intercept would be b, and the slope would be d. From here we can get our line. So you might ask yourself, what is the difference between an arithmetic sequence and a linear function? Well, the truth is, there isn't that much of a difference. One of the biggest things is how we write it. But also something that's really important is this n and this x. X normally refers to any number. It can be an integer like 1, 2. It could be pi. It could be 2.3. It could be anything. But in the case of n, it's always just integers. In fact, positive integers. So, for this case, you can't say when n equals 2.2. At least, that's not exactly correct. If you wanted to do something like that, you should be using x. Again, I've been very vague in this lesson, so please use the examples to further your knowledge in this matter.